Hey, this is actually lesson 13.2, but it's an extension of 13.2. So it's 13.2 extension, and we're talking about slopes still, but this is slopes of parallel lines and perpendicular lines. Let's start with parallel lines. Parallel lines and slopes. It says lines in the same plane that do not intersect are parallel lines. Well, we already knew that. Non-vertical parallel lines have the same slope. And the reason they had to put that non-vertical part in there is because remember, a vertical line, one that goes straight up and down, it has undefined slope. It doesn't have a slope, it's undefined. So they couldn't just say parallel lines have the same slope, because then what somebody would say, well, what about vertical lines? And so they had to put that in here, and it says all vertical lines are parallel. But we're going to talk about non-vertical lines right now. We're going to talk about this blue line and this red line right here. They are parallel. And we can tell they're parallel not just because, well, they sure do look parallel, because they could just be off by the tiniest bit and they're still going to look parallel to us. The reason we know that they're parallel is because they both have the same slope. The slope of each of these lines, if you'll look, here's a spot where it goes through the intersection, and here's another spot it goes through the intersection. This goes up 1 over 2. So a slope of 1/2, or 1 over 2. And down here, we have it go through the intersection here and intersection here. Rise over run is 1 over 2. So they both have a slope of 1 over 2, or 1/2. And that, therefore, they are parallel lines. So now let's look down here. Here's a problem. It says, which two lines are parallel and how do you know? So looking at these three lines, if you look at those, they all look parallel to me. They're not all parallel, but they look parallel. So what we have to do is just find the slope of each line, and two of them will have the same slope. Those two are the parallel lines. So find the slope. We can do rise over run. So this one goes up 1, 2, 3, 4. And over 1. So this blue one would have a slope of 4 over 1. Now they found that over here by doing change in y over change in x. That works as well. But because we could just do the rise over run, I find that easier to do when we can. This red one, 1, 2, 3, 4, 5 over 1. So this would actually be 5 over 1 for the slope. And then this one, so here was 4 over 1. Here was 5 over 1. We know they're not parallel to each other. This one's going to be parallel to one of them. And let's see, it goes 1, 2, 3, 4, 1. So 4 over 1. The blue and the green each have slopes of 4 over 1, or just slope of 4. And the red has a slope of 5 over 1. So although it looks parallel, it's only the blue and the green that are parallel. And how do we know? Because they have the same slope. So here's some problems down here for us. Practice. Which lines are parallel and how do you know? Which lines are parallel and how do you know? So we go to these right here. And for number 1, just looking at these, we'll go with the blue line first. So I'll just put a B here for blue. And we can go, it goes up 1. Oh, actually, you go from left to right. So we're going from this dot here. It actually doesn't go up, it goes down, which makes sense because all of these are sloping down going from left to right, so they'll all have negative slopes. So this comes down 1, 2, 3. So negative 3 for the rise because it was coming down, and over 1. So negative 3 over 1. The red line has 1, 2, 3. So it came down 3, so a negative 3 again, and over 1. And the green line comes down 1, 2, 3, 4, and then over 1. So this is negative 4 over 1. So the slope of the blue line, since it's over 1, it's just negative 3. The slope of the red line, negative 3. The slope of the green line, negative 4. So which lines are parallel? Blue and red. How do you know? Because they have the same slopes. Blue and red both have a slope of negative 3. For number 2, so that was number 1. for number 2, same kind of problem. We have to find out which ones are parallel, and how do we know? So the blue line has a slope of, now these are all positive slopes because they're going up from left to right. 1, 2, 3, 4, 5. 1, 2, 3. Up 5 over 3. The red line. 1, 2, 3, 4. 1, 2, 3. 4 over 3. And the green line. 1, 2, 3, 4. 1, 2, 3. 4 over 3. So, which lines are parallel? The red and the green lines. How do you know? Because they both have a slope of 4 over 3. Are the given lines parallel? Well, if you look here, y equals negative 5 and y equals negative 3. The y equals negative 5 would just be a horizontal line at negative 5. So 1, 2, 3, 4. Be just down here, one line under. And this is y equals 3. That would be a horizontal line at 3. So yes, they are parallel. And why? Because they're both horizontal lines. This, y equals 0, is the x-axis. X equals 0 is the y-axis. Are those parallel? No, they cross right there. So number 4, no. Explain your reasoning. The first line is vertical or horizontal. The second line is vertical. And for number 5, are these parallel? Yes. And you would not say because they have the same slope. You would put because they're both vertical lines. Remember, they don't have a slope. It's undefined. Well, that takes care of parallel lines. Then we have perpendicular lines. And perpendicular lines, lines in the same plane that intersect at right angles, are perpendicular lines. Two non-vertical lines, so again, they've got to take care of the vertical line problem because they don't have slopes. Two non-vertical lines are perpendicular when the product of their slopes is negative 1. And then it says vertical lines are perpendicular to horizontal lines. And hopefully we knew that. It's kind of like the two axes here. This is the vertical, this is the horizontal, and where they cross, that's a right angle, so they're perpendicular. So when it says their product of the slopes is negative 1, you can also say that one slope is the negative reciprocal. Remember, that means we flip the fraction over. The negative reciprocal of the other. So let's take a look at this one right here. Which two lines are perpendicular? How do you know? Well, you know it's going to be the green and the red or the green and the blue. It would definitely not be the blue and the red. They're not going to cross at a right angle. They'll probably cross about a mile down that way somewhere, but who cares? We just know it's going to be either the green and the blue or the green and the red. So let's figure out what the slope of the green line is first. And it goes from here. It goes, this time instead of just counting up and over, which we could do, and we would get 1, 2, 3, 4, 5, 6, 7 over 2. Just rise over run. Instead of doing that this time, let's do change in y over change in x. So we're going to look at the y values. 5 minus negative 2. 5 minus negative 2 over 0 over the x values. Minus negative 2. Minus negative 2. Remember, we turn these into big pluses here. 5 plus 2 is 7. And 0 plus 2 is 2. So the slope of the green line is 7 over 2. If I'm looking for its perpendicular, which I am, then I want to find the slope of one of these lines, either the blue or the red, to be the negative of this. So it'll be negative, and the reciprocal. So I take that and I flip it over. So I'm looking for one that'll be negative 2 over 7. If I multiply these two together, I get negative 14 over 14, which is just negative 1, which is what it said. Okay, so I'm going to do both of these here. The blue line first. Blue. And we'll do it the same way. We'll do 4 minus 6 for the change in y, and 1 minus negative 5. 1 minus negative 5 for the change in x. Big plus there. 4 minus 6 is negative 2. 1 plus 5 is 6. So negative 2 over 6, which you could simplify to negative 1 over 3. Not what we were looking for. So let's give the red line a go. Change in y, so negative 2 minus 0. And 2 minus negative 5. Change that into a big plus. Negative 2 minus 0 is negative 2. 2 plus 5 is 7. So that is what we wanted. Negative 2 over 7 and 7 over 2. They're negative reciprocals of each other. Remember, reciprocal means we flip it over, and one's negative and one's positive. So the green line and the red line are perpendicular to each other, and the blue line is just like in the way. And we'll do one of these down here. Which lines are perpendicular? How do you know? Well, we'll do the same thing, that's why. Then let's look at these really quickly. Are the given lines perpendicular? Explain your reasoning. This is x equals negative 2, which would be a vertical line at negative 2 for x. Y equals 8 would be a horizontal line at y equals 8. So those would be perpendicular because one's vertical and one's horizontal. Here are two vertical lines. They are parallel, of course, but they are not perpendicular. And here, again, we have the two axes. Y equals 0 is just the x-axis, and x equals 0 is the y-axis. Of course, they are perpendicular because one's horizontal and one's vertical. Okay, so now we'll just do this first one here, number 7. And the green is the one that's going to be perpendicular to one of those two, so let's do that one first. And this is a negative slope, so for green, and we'll just go, it goes down 1 and over 1, 2, 3, 4, 5, 6. So down 1, negative 1 over 6. The blue is 1, 2, 3, 4, 5, 6 over 1. And the red is 1, 2, 3, 4, 5 over 1. So we look here, the green, if we take the negative reciprocal, well, the negative of the negative, so that'll be back to a positive, and reciprocal means we flip this over. So a positive 6 over 1, and it's right there, the blue. So the green and the blue are perpendicular because their slopes are the negative reciprocal of each other, and this is just a nothing. Excellent. Well, give the homework extension 13.2 a shot, and we'll see how you do. P.S. The homework is 2 pages. It is front and back, so it's 301 and 302 out of your journal. See ya!